Everything's going okay and you're not too overwhelmed, but this is the math behind it, okay? And this is where I always say, I'm doing math with my son who's in grade 7 right now, and so you had to explain your thinking for everything. When you used to do math in elementary school, this is the exact same thing. If you can explain how it works mathematically to get the ratio of these ions that are in an ionic particle, then I think you really do show some understanding, okay? Here's the math that you do to figure this out. So it's called the zero-sum rule. It simply means that the sum of the charges in a chemical formula have to equal 0 because it's a stable, happy particle. That's how particles are made. They both want to become stable ions, or stable atoms. So to be able to do that, metals will give away electrons and non-metals will gain electrons, okay? This model helps you to understand the idea. It shows that 2 negative chloride ions are required to satisfy or balance out the positive magnesium ion, and the overall charge is 0. Each ion has a charge, but the overall compound that forms has no charge. So the sum of that together is equal to 0. Okay, how do you do that? There's our diagram if you need to, and the textbook does a good understanding of this as well. Okay, I'm going to show you using the couple of examples that I've already filled in for you. Here we go. Let's say you have to make a compound that has sodium and fluorine in it. What ratio are those atoms going to come together in to make a stable, happy particle? Okay, sodium's in group number 1, it has a 1 plus charge. Fluorine's in group number 7, that ion will have a 1 minus charge. They come together in a 1-to-1 ratio to make a compound NaF. What's the name of that compound? You take the metal first, the non-metal, and add the IDE on the end. That compound will be called sodium fluoride. It's ionic because it's a metal and a non-metal. That's all we've been doing so far. And here's the zero-sum rule. I have one thing of sodium. Each sodium has a 1 plus charge. I have one thing of fluorine. Each fluorine has a 1 minus charge. Plus 1 minus 1 equals 0. The sum of the charges of the ions in that formula total to be 0. Okay, you could reverse that and figure out what the charge of one of those ions would be, can't you? That's in the next part. Here's your oh shoot, I wrote this one wrong. It wasn't magnesium fluoride. It is magnesium and sulfur is going to come together to make magnesium sulfide. All you do is change the ending to IDE. Magnesium's in group number 2. It's going to have a 2 plus charge. Sulfur is in group number 6. It has 6 valence electrons. Its ionic charge is going to be 2 negative. 2 plus, 2 negative. It comes together. You'd think it's going to be a 2-2, but you reduce it to a 1-to-1 ratio. Why? Because you have one thing with a 2 plus charge. You have one thing with a 2 negative charge. Plus 2, negative 2 equals 0. And reducing that compound to the lowest whole number is what you do for ionic particles. Okay? Is there a cheater version of this? Yes. Can I show you? Sure. Only if you already understand what's going on. Okay? This is called the crisscross rule. Are you ready? I write the ionic charge as a superscript right beside my element. Calcium's in group number 2. It wants to get rid of those 2 electrons. It's going to have an ionic charge of plus 2. You remember chlorine? Yep, you know that chlorine's in group number 7. 7 valence electrons. It has a 1 minus charge. Okay? Now watch. This is the cheater version, and it only will show you an easy way to figure out the ratios that these guys are going to come together. First of all, can you figure it out? Can you see that you're going to have 1 calcium and 2 chlorines based on if you did the Bohr-Rutherford diagram and the Lewis dot structure? That's the ratio you're going to need. Does that make sense? If you already know the answer and you know that it's going to be a 1-to-2 ratio, then you can do the cheater version, which is the crisscross version. I take this number here and I use it to help figure out the subscript down here. I take this number here and I use it to figure out the subscript down here. Crisscross the ionic charges to give you the number of the ions in that particle. Ca1. You don't have to write a 1 because by having a 1, you already have. That means there is one. Cl2. Do you see that? That is my compound that forms, and it's called calcium chloride. Okay. That's a lot for this part of ionic particles. Give it a go, do your homework, and then I want you to watch the next section of the video, and I'm going to show you what you do with those transition metals if there is more than one ionic charge for the metals that are in the middle of the periodic table. Okay, good luck.